In this demo, we will introduce the Nokia Deepfield DDoS security solution and show how it can accurately, quickly, and in seconds protect your network and customers against distributed denial of service attacks. Distributed denial of service, or DDoS, has grown in its intensity, sophistication, and frequency over the last couple of years. Today, we see all elements and parts of the internet ecosystem equally vulnerable and prone to being attacked by DDoS, from service providers to new digital service providers, and including all elements in the internet ecosystem, from content delivery networks, CDNs, to internet exchange points, IXPs, all the way to end users, enterprises or residential users. The DDoS threat landscape has changed immensely over the last couple of years, especially given the proliferation of insecure IoT devices. We should all be worried about the immense growth in the number of IoT devices and the large number of insecure or compromised IoT devices that could be employed for malicious purposes. Only 7 years ago, the monthly price to launch a 100 gigabit per second DDoS attack was around $1,000 or euros. Today, this price has gone down significantly to only a fraction of that. Even worse, today, it is very easy for malicious parties to identify a particular IoT device and quickly find the exploit or toolkit that can make it part of their botnet. Then, the IoT device can be compromised and added to the botnet, which can launch some of these very potent and intense DDoS attacks on any arbitrary target. The problem of insecure IoT is compounded by the rise in gigabit and multi-gigabit connectivity on the access side. More bandwidth fuels insecure IoT devices with power to deliver stronger and more impactful attacks, targeting systems, hosts, and end users across the internet. Traditionally, most DDoS comes from outside networks, what we call inbound, coming from the internet and directed on customers and enterprises in service provider networks. Today, we are seeing a growing occurrence of outbound DDoS, originating from exploited and insecure systems in wireline and wireless domains, including enterprise customers, and sent at targets outside of the service provider domain. Both infrastructure targets, such as the broadband IP edge, IP core, cloud data centers, or towards other targets out on the internet. The next generation anti-DDoS solution needs to be more efficient than legacy solutions when dealing with the latest and future generations of DDoS attacks. First, we need a fast and accurate AI-driven DDoS detection that must result in reduced false positives and negatives. We also need comprehensive protection against all types of DDoS attacks, be they volumetric, application layer, or botnet-driven carpet bombing, as well as all potential future DDoS attacks. We need behavioral and zero-day protection that would stop DDoS attacks as they emerge. We also need rapid and granular AI-driven auto-mitigation and to leverage network edge capabilities for network-based mitigation whenever possible. Network-based mitigation, performed by network routers, is the most efficient way of dealing with the most impactful volumetric traffic. But let's take a look at typical DDoS attacks today. Here, we will outline a couple of examples. In our first example, we are looking at the carpet bombing attack that is originating from a very large number of sources. As you can see on the left-hand part of the screen, we have more than 100,000 source IP addresses attacking the whole subnet domain, 256 IP addresses. That is why we call this type of attack a carpet bombing attack. This attack is peaking over 1.4 terabits per second and has a very high packet intensity rate of 127 million packets per second. The decomposition of the attack is also shown here, listing the attack vectors that comprise this attack. This attack is predominantly composed of DNS amplification, but there are additional strong DDoS vectors, including botnet DDoS and DNS flooding. This was a real-world attack that we were able to stop in 29 seconds with very high efficiency, which means a very low rate of false positives and false negatives. We compared our solution's performance in stopping this particular attack against the performance of the next best competitor solution. In the case of our key competitor, even after 3 minutes, while their mitigation is at its peak, a lot of DDoS traffic is still passing through. This is because our competitor's solution did not detect the DDoS attack in its entirety and is still passing some DDoS traffic with a very high false negative rate, assuming it's good network traffic. Let's now look at the second example, also taken from a recent real-world attack. Here we are dealing with a very complex attack that was constructed as a series of 4 consecutive attacks happening in time, one after another, each one adding to the previous. That is why we have this compounding effect of 4-stage complex DDoS attack. As mentioned, this example was taken from a real network. On the bottom of the screen, we are showing in yellow the customer traffic. From this chart, you can see that we have been able to neutralize all these DDoS attacks within seconds, and not just DDoS traffic from one attack, but from all 4 of them as they happen in real time. As an explanation, we show each of these attacks decomposed in separate pop-up screens like this one. The first stage of this complex attack was a TCP/ACK carpet bombing attack with a very high number of sources, almost 800,000 IP addresses, targeting the whole subnet segment. The attack vectors in this stage were predominantly TCP flood and UDP flood. The second stage of this combined multi-stage attack used botnet with random UDP, targeting one IP address from a fairly large number of source IP addresses, with a lot of packet intensity aimed at the enterprise customer. The third attack in this series was a multi-vector amplification, originating from about 20,000 source IPs, again targeting just a single IP target. This attack was predominantly DNS-based, which, by the way, constitutes most of the attacks we still see on the internet. And the fourth attack in this series was TCP/SYN flood carpet bombing attack, again targeting a wide range of targets, 90 IP addresses from almost 50,000 source IPs. With the Nokia DDoS security solution, we have been able to neutralize all 4 attacks, which were just stages of a large DDoS campaign, within seconds and return to normal values for the baseline of good traffic for this customer, which is shown at the bottom of this diagram. So, let's talk about the Nokia DDoS security solution. The Nokia DDoS security solution combines 2 cutting-edge technologies. One of them is the AI and ML-driven big data network security analytics that comes from Deepfield Defender. This software application uses Deepfield Secure Genome as a real-time database, which provides security context from the whole internet. The other element of our solution is sophisticated mitigation instruments, such as Nokia IP routers or a dedicated mitigation system. With these 2 technologies combined, we are able to detect DDoS attacks as they happen and mitigate them with great efficiency and cost efficiency in real time, in seconds. Deepfield Defender detects DDoS with great accuracy and speed, mainly thanks to Deepfield Secure Genome, a living database that provides internet-wide security context and knows the security details of over 5 billion IPv4 and IPv6 addresses. Secure Genome continuously scans and categorizes IP addresses on the internet and implements AI and ML technology for supervised learning and model training. Secure Genome contains knowledge and up-to-date visibility into DDoS, vectors, botnets, server software versions, and common vulnerabilities and exploits, known open reflectors, booter and spoofed fingerprints, and IoT devices. Information from the network itself and Deepfield Secure Genome is correlated by Deepfield Defender. Once a DDoS attack is detected, mitigation needs to be devised. In Defender, we have the mitigation compiler engine, a core that creates a mitigation strategy on the fly, taking into consideration real network capabilities and information about a particular DDoS attack. The mitigation compiler engine gets its input from Deepfield Secure Genome, the network itself, and our proprietary DDoS library, one of the largest DDoS sample libraries in the world. By virtue of AI and ML technologies and supervised learning, Mitigation Compiler Engine compiles a network-specific mitigation strategy that is most appropriate and most optimal for a particular network, taking into consideration the actual network capabilities and the capabilities of precise mitigation instruments that a network has at its disposal. For example, Nokia FP4, FP5, or FPCX-based IP routers, dedicated mitigation system like 7750 Defender Mitigation System, or third-party IP routers such as Juniper MX. When we talk about network-based mitigation, we think about mitigation performed by the network itself, in this case, IP routers. We at Nokia have been advocating this approach for quite some time, considering the Nokia-based network that is powered by FP4, FP5, or FPCX network processors. Our philosophy for building these advanced capabilities into IP routers has been embodied in Secure by Design principle. We believe that security should be thought of from product design and inception, and not added as a bolt-on addition later. Industry-leading high processing power of these processors allows Nokia routers to perform additional security-related functions without affecting their primary task, which is high-performance routing and packet switching. While the network-based approach for neutralizing volumetric DDoS provides protection against the most impactful and bandwidth-intensive DDoS attacks, there is a growing concern about other types of DDoS, such as botnet DDoS, carpet bombing DDoS, and application layer attacks. In 2023, we released the 7750 Defender Mitigation System, and in 2024, we added advanced countermeasures to its feature list. This FP5 network processor-based system comes with up to 2.8 terabit per second capacity in a compact form. It's a 2-rack unit for the main Defender Mitigation System, with 1 rack unit high element shown on top that provides advanced countermeasures for Layer 4 to Layer 7 DDoS countermeasures. So, a 3-rack unit high system. Defender Mitigation System runs on an optimized variant of the SROS for mitigation of distributed denial of service traffic. It is fully Deepfield Defender UX and API managed. In addition to processing volumetric DDoS traffic, it provides the advanced countermeasure engine for processing Layer 4 to Layer 7 DDoS traffic as well. The 7750 DMS provides superior protection against all types of distributed denial of service attacks, volumetric, botnet, and application layer attacks, and delivers industry-leading scale performance, power, and cost efficiency. Now, if we go back to the requirements for a next-generation DDoS security solution, we see that the Nokia Deepfield DDoS security solution ticks all the boxes and more. AI-driven DDoS detection mitigation, terabit-scale, protection against all DDoS types, volumetric, botnet, carpet bombing, and application layer. With accurate and fast detection thanks to Deepfield Secure Genome. Granular, automated network-optimized mitigation in seconds, either using the network-based mitigation by routers or by using a dedicated next-generation scrubbing system, the 7750 Defender Mitigation System. In addition to all of this, the Deepfield Defender-based solution allows service providers to expand their service offering and offer security as a managed service to their customers. This is about providing anti-DDoS as a service using the Managed Security Service Portal and customization. I hope you liked this short demo. Please contact us to show you a real demo. Feel free to reach us for more information on how we can help you defend your network, services, and customers against distributed denial of service, or DDoS.